Hello friends, my name is D. Raju. I am working as lecturer in chemistry at Government College Autonomous, Anantapur. Today we will discuss about the topic called Introduction to Thermodynamics. So here the learning objectives of this topic are to know about the definition of thermodynamics, the importance of thermodynamics, important terms and definitions like types of systems, so what are the various types of systems present, and what are extensive and intensive properties, what are state and path functions, what are the examples for them, what is heat, what is the concept of work, and what are the various types of processes involved in thermodynamics like adiabatic process, isothermal process, cyclic process, etc. Now we will go to the introduction part. Here the thermodynamics is the branch of science which gives the relationship between heat energy and mechanical energy. That means how heat energy can be converted to mechanical energy and how mechanical energy can be converted to heat energy, and what are the laws which gives the relationship, and all these things we can discuss here. But earlier the primary goal of thermodynamics was to increase the efficiency of heat engines. That is, how can we get maximum work out of a given amount of heat. But the scope of this branch has increased tremendously, that now this branch is useful to study the stability of substances, to study about the chemical equilibriums, and also the feasibility of a process. That means whether a particular reaction is feasible or not. That is, the spontaneity of reactions also can be explained with the help of thermodynamics. Now we will move on to the some of the other basic concepts like system and surroundings. First one is the system and surroundings. So system is nothing but the part of the universe which is under observation. That means the part what we are observing is called a system. System may be like gas present in a cylinder, or a water boiling in a vessel, anything else. So the part of the universe which is under observation is called system, and the remaining part is called as surroundings. That means everything apart from the system is called as surroundings. So that means the system and surroundings both comprise the universe. So here with the help of this diagram we can see here. So for example, I will show you here. So this part is the system, and this particular portion is system, and all the remaining portion. So throughout this box the remaining portion is nothing but the surrounding. Discuss about the types of systems. There are three types of systems present in the study of thermodynamics. One is open system. Open system means this is a system from which both heat and matter can be exchanged with the surroundings. So the heat also can be exchanged with the surroundings, and matter also can be exchanged between the system and surroundings. So here let us suppose this green color box is the system and the outer color blue color box is the surroundings. So here the heat and matter both can be exchanged between these two parts, that is system and surroundings, and this can be taken as an open system. Example for this one is a hot water in vessel without lid. That means the hot water can exchange its hotness with the surroundings as well as the water present in it with the surroundings. So therefore this can be taken as open system. And the second one is the closed system. So here closed system means only heat exchange takes place between the system and surroundings, but not the matter. Matter will remain within the system itself. It cannot escape from system to the surroundings. For example, if you take a pressure cooker with a tight lid, then it cannot exchange matter which is present inside it with the surroundings, but only heat can be exchanged with the surroundings. So therefore, this can be taken as an example for a closed system. So heat can be exchanged between the system and surroundings, but not the matter in closed system. And the third type is isolated system. In isolated system, neither the heat nor the matter can be exchanged between the system and surroundings. That means if the walls of a particular system are made of insulating walls, then what happens? The heat and matter both cannot be exchanged with the surroundings. For example, if you take a thermos flask, it cannot exchange its hotness with the surroundings. It cannot exchange the substance which is present inside it with the surroundings. Therefore, this thermos flask can be taken as an example for an isolated system. So, open system, closed system, isolated system, these three systems comes under the types of systems in the study of thermodynamics. Next, we will move on to the concept of extensive and intensive properties. So, what are these extensive properties and what are these intensive properties and what are the examples for them? First, extensive properties. Extensive properties, they depend on the quantity of substance present in the system. So, they depend on the quantity present in the system. For example, mass, volume or entropy, heat capacity, internal energy, enthalpy, all these parameters, they depend on amount of substance present in the system. So therefore they can be called as extensive properties. Intensive properties. Intensive properties are nothing but these are the characteristic properties of the substance which is present in the system. For example, if you take density, density does not depend on the amount of the substance. It is the characteristic property of that particular substance. So these types of properties like density, viscosity coefficient, specific heat, calorific value, chemical potential. So these things, they are independent of quantity of substance present in the system and they can be called as intensive properties. Next, these extensive and intensive properties can be explained here with an example. What we will do, we will take a container. In this container, gas is present and the volume of this container is V and the temperature is T. That means the volume of the gas is V and the temperature of the gas is T. Next, what we will do, we will half the container. That means the volume of the container is halved. That means we are dividing the container into two equal halves. So then what happens to the volume and what happens to the temperature? Volume becomes half because you are dividing the container into two equal halves. So volume is becoming half. So therefore the V is becoming V by 2 in left side and V by 2 in right side compartment. Whereas the temperature is remaining constant. In left side compartment or right side compartment, the temperature will be T only. So therefore from this point or from this illustration we can say that volume is an extensive property because it is depending on the amount. Whereas temperature is an intensive property because it is independent of amount of the substance present in the system. Next, we will move on to the concept of state function and path function. So what are these state functions and what are these path functions? State functions depend on state of the system. So at what state the system is present? So these parameters like temperature, internal energy, enthalpy, free energy, entropy, all these parameters, they depend on the state of the system. Whereas some of the parameters like work, heat, they do not depend on the state of the system, but they depend only on the path followed by the system. So whenever the path changes, the value of this work and heat will change. Whereas for state functions, only those will depend on the state of the system but not on the path followed by the system. This we can be explained here with the help of an example. Let us suppose here the system is present at initial stage and its internal energy is Ui. So Ui is nothing but the initial internal energy of the system, and this system is undergoing some change in two paths. This is path 1. Along the path 1 it is undergoing change, and in other way it is undergoing some change in path 2. So here the system is finally reaching the state UF, that is the final internal energy UF. So in this green color path it is undergoing adiabatic change, whereas in this orange color path it is undergoing non-adiabatic change. So in path 1, because it is an adiabatic process, here the Q is equal to 0. That means there will not be any exchange of heat between this system with the surroundings. So therefore its Q value becomes 0. Whereas W is not equal to 0. W will have certain value. Let us suppose X. Now go to the other case. In this path 2, the system is undergoing change from UI to UF state. In this process, because it is being non-adiabatic path, Q is not equal to 0. That means Q will have some value, and also W work also will have some value, whereas this work here is not equal to X, but it may be Y. That means the work value in adiabatic path, the work value in non-adiabatic path, both are different. So that means what? These Q and W values are depending on the path followed by the system, but not on the state of the system. Whereas if you take internal energy, UI will have certain value, UF will have certain value. So they are not depending on the path followed. UF is not depending on the path 1 or path 2, but it is only depending on the state. So therefore this internal energy can be taken as as a state function. Work and heat can be taken as path functions. Now we will move on to the concept called internal energy. So this internal energy is nothing but the total energy possessed by the system. That means total energy means there will be two types of energies. One is kinetic energy, other one is potential energy. By the virtue of arrangement, the energy gained by that particular system is called as potential energy, and by the movement of molecules, the energy is called as kinetic energy. So internal energy is the sum of kinetic and potential energies. In thermodynamics, only change in internal energy of a particular system is required, but not the exact value of U. Only the change in internal energy. If a system is undergoing change from one state to the other state, what is the change in internal energy is only required. Actual value of U is not required, because we cannot determine this actual value of U, because this U, as we discussed, is the sum of kinetic energy and potential energy, and kinetic energy is equal to the sum of translational, rotational and vibrational energies, and the values for these energies cannot be determined accurately. So only the change in internal energy is required for us. Then we will go to the concept called heat. So heat is, as we discussed, it's a path function and it is not possessed by the system. That means system will not have this particular value of heat, but whenever the system undergo change, it will release or it will absorb the heat. That means energy in the form of heat. That means it is not possessed by the system but appears when the system undergo change. The Q value can be determined with the help of this equation, m into S into delta T. M means its mass, S is specific heat of that particular substance, and delta T is the change in temperature. So during that process, so what is the change in temperature? So if we substitute these values here, we will get the Q value. And Q will have two signs. One is positive, other one is negative. If final temperature is greater than initial temperature, that means if the system is undergoing a change in such a way that its temperature is increasing, then so delta T becomes positive here, the Q total Q value becomes positive here, because M and S always will have positive values. So if T final is greater than T initial, the heat is absorbed by the system. To increase the temperature, the system has to absorb the energy. So here the Q value is positive and this becomes endothermic reaction. So in endothermic reactions, Q becomes positive. If For example, final temperature is less than initial temperature. That means, what does it mean? The system is giving out some energy in the form of heat. Then delta T becomes negative. If delta T is becoming negative, Q becomes negative. So therefore, for exothermic reaction or the reactions in which heat energy is evolved, so for those reactions, Q value will be negative. Now we will go to the concept called work. So similarly like heat, work is also not possessed by the system but appears when the system undergoes some change. So if we say, for example, there is an expansion work, a gas is undergoing expansion, then its W can be calculated with the help of this equation minus P external into delta V. P external means external pressure against which the gas is undergoing expansion, and delta V is the change in value. So how much volume of the gas is changed there. So we can have two types of works depending on the sign. For example, let us say for example expansion work. Here V final will be greater than V initial. That means what? Volume is increasing, that is expansion. And what W becomes? As V final is greater than V initial, delta V becomes positive and W becomes negative. That means in expansion the W will have negative sign. So we will see here. This is the system and this is the surroundings, and the system is undergoing expansion. That means system is doing some work on the surroundings so that its volume is increasing. So this is the expansion. So in the process of expansion or where W value is negative, the system is doing the work on the surroundings. That means work done by the system on the surroundings. For them W becomes negative. In the second case, opposite to this one, if final volume is less than initial volume, what does it mean? Volume is decreasing. Volume is decreasing means what it is? Compression. So if the process is compression, delta V becomes negative and total W becomes positive, because here minus sign is there and delta V becomes minus value, minus into minus becomes plus, so W becomes positive value in compression. So when will this compression will occur? When the surroundings will do the work on the system. That means surroundings are doing some work on the system so that the volume of the system is decreasing, and that is the example for compression. So in this compression work, W value will have positive value. Next we will move on to the process called isothermal process. Isothermal process means the process where the temperature remains constant. That means change in temperature is equal to 0. So here change in temperature is equal to 0, but heat exchange takes place between the system and surroundings. Because let us suppose if the process is an exothermic process. So what happens in exothermic process? Heat will be liberated, and if this liberated heat is not given to the surroundings, then the temperature of the system will increase. So then it cannot become an isothermal process. So to maintain the temperature constant, the liberated heat should be given out to the surroundings. In opposite way, in endothermic process, if the heat is required, so the heat should be absorbed from the surroundings, because system has to maintain its temperature constant. So this is the isothermal process. Now adiabatic process. In adiabatic process, no heat exchange takes place between the system and surroundings. That means change in Q value is 0. That means what? So system cannot exchange heat with the surroundings. So therefore what happens? Temperature of the system is not a constant one. Because if the process is exothermic, let us suppose, the liberated energy cannot be given out to the surroundings. The system itself has to absorb that energy. So therefore temperature of the system increases. For example, if the process is endothermic, so that means what? Heat cannot be supplied from surroundings here. So system itself has to utilize its internal energy for that heat. So therefore what happens? The temperature of the system decreases because it is utilizing its internal energy. So therefore its temperature will decrease. So in adiabatic process, there will not be heat exchange between the system and surroundings, whereas the temperature will not remain constant. Then isobaric process. So in isobaric process, change in pressure is 0. That means system and surroundings both will have the same pressure. So generally the processes which are carried out in open vessels comes under isobaric processes. In isobaric processes, so volume will change. Next, isochoric process. In this isochoric process, the change in volume is zero. That means volume remains constant, whereas the pressure may be changed in these processes. So the reactions which are taking place in bomb calorimeters, autoclaves are the examples for these isochoric processes. Now we will go to the important concept called cyclic process. So the name itself indicates in cyclic process the system undergoes many changes and comes back to the initial state. See here, initially the system is present at state 1 and it is undergoing some change and going to state 2. From 2 to 3 it is undergoing some change, and from 3 to 4 it is undergoing some change, and from 4 to 1 again it is coming back to the original place 1. That means it is undergoing some change from 4 to 1 and such a way that it is reaching 1. So the initial and final states of the system are same in the cyclic process. So system undergoes many changes and come back to the initial state. So that means what? State is not changing. State is not changing means what? State functions remain constant. There will not be any change in the state functions because U, internal energy, T, temperature, H, enthalpy, S, entropy, all these parameters or quantities are the state functions. Therefore their change in their value becomes 0. So whereas the state functions are remaining constant here, but work is performed and heat is consumed in these processes. That means heat and work exchanges takes place between the system and surroundings, and so work and the heat values, they do not remain same. Next we will move on to the other concept called reversible and irreversible process. So reversible process, it is a hypothetical process. So it takes place very slowly. At each and every stage there will be equilibrium establishes between the initial and final states, and here the driving force is only minutely greater than the opposing force. In a very small amount the driving force is greater than the opposing force. So in this process at each stage there will be equilibrium between the initial and final states. So therefore to produce a big change, net change, this process should be repeated for infinite times. So this process is called as reversible process, and this is a hypothetical concept. So we will discuss about this one with an example in the next slide. Now we will go to the irreversible process. So a reversible process is the process where the system undergoes change suddenly. That means it is not a very slow process, it's a fast process, and it takes place in a single step, not in multiple steps, very slow steps. No, the system will undergo the change in a single step. So that process is called as irreversible process. We will take these things with an example here. Let us suppose here this green color box is a cylinder and this orange color rod is a piston. So gas is present inside the cylinder whose pressure is P. Its pressure value is P. And outside pressure P external, let us suppose P external is equal to P. That means pressure of the gas inside the cylinder and outside pressure both are same. Then there will be equilibrium between these things. Let us suppose if piston is getting expanded with this gas to a certain extent, small extent, like dV. That means this piston is getting expanded in such a way that the volume of the gas is increasing to a small extent dV. When it will happen? When this P value is little greater than external pressure. If the value of P is little greater than this external pressure, then the piston will move up, and again the equilibrium establishes between the outside surroundings and the gas present inside the cylinder. And these type of small changes takes place at every stage, and this process will be repeated for infinite times in reversible expansion. If we go for irreversible expansion, the expansion occurs suddenly that volume increases, volume of the gas increases more, not in very small quantities, but volume will increase at a single stretch. See here, the volume is increasing more. When this will happen? When the external pressure is much lesser than the pressure which is present inside the cylinder, then the sudden expansion will take place, and this can be taken as an example for irreversible expansion. So these are some of the references where you will get more information about these topics regarding thermodynamics. So thank you very much. Thanks for watching.